Welcome to one of the most important lessons that we do of the entire year. Today's going to be an introduction about significance tests, and it's going to be something that we come back to over and over and over again for the next couple of units. So you'll notice a bunch of key vocabulary here. I do want to say this is all new vocab. You've not really talked about any of it this entire year, so there's a lot to process here. So please make sure you take your time with this lesson and that you do fully understand it. So we are going to look at this question back in my yesteryear. That's me. Yep. Does Mr. Mills have long hair in that picture? It sure does. I did have some longer hair and I did play basketball. Never good enough to make the school team, but it's okay. I've gotten over it in years since. So I have this claim that I make 80% of my free throws. And to prove that, I'm going to take 50 shots. So I shot 50 free throws and I made 32. So now we have this question like, do you think I'm lying? Am I exaggerating in how good that I am? So that's the question we're going to be trying to answer here. So if we think about the population, well, the sample is the 50 free throws. So the sample is the 50 free throws. And the population would be all free throws by Mr. Mills. Okay, we only looked at the 50 that I took. The parameter, we're looking at a categorical variable. I made it or I missed it, so this would be a proportion. So the parameter would be P, and this would just represent the true proportion of free throws made. And then we also have the statistic, which is the sample proportion of free throws made, and we do have a specific value, 32 divided by 50, which is 64%. So now we need to think about, like, what are the explanations, there's two, on why I only made 32 out of 50 shots. So I'd encourage you to pause the video now and see what you can come up with or brainstorm. So one explanation is, you know, I just had an off day. I'm usually really good, but I just had an off day and it happened by chance. So I would say that it happened by chance. And I'm just going to put in parentheses, had an off day. I am an 80% free throw shooter. Just, I don't know, that day, I stunk it up. The other scenario is that I'm lying or I'm exaggerating. Exaggerating. A-G-G-E-R. I believe that's how you spell exaggerating. So what that would mean is P is really less than 80%. That true proportion is really less than 80%. So here's what we're going to do. We're going to test this claim. In order to do that, we are going to assume that I am an 80% free throw shooter, and it just happened by chance. The way we're going to do that is through a simulation, in which we've done numerous times. So onto the second page here. I'm going to pause this because I got to bring up this graph. Okay, I'm back and I have the online spinner loaded, so hopefully you have yours loaded up. Basically, you'll notice on the spinner there are 10 equal spots in terms of area. The colors mean absolutely nothing. The first few times that I used this, I was very confused by that. You're just going to click to spin, listen to the fun noises, and it's going to tell you, is it a make or a miss? So I made the first shot, made the second, made the third, made the fourth, made the fifth. So you get the idea here. So going back here, you're going to do this 50 times. So, and I'm just going to keep a tally. I made the first 5. I could keep going. Now, I did misspeak. That simulation that we were just running through was not me shooting. It's somebody who is an 80% free throw shooter. It might be me. We're trying to gather evidence to see if that's the case or not. So here's the deal. After you get your 50 shots, say I made 38 out of the 50. That's going to be my sample proportion. And you're going to have your own data. Okay, so now I'm going to go to this other link, and I'm going to change the proportion to 0.8. That's my claim that I make 80% of my free throws. The sample size to 50. It's already there. I'm going to draw 1,000 samples. You actually have to click the button to do that. And there we go. There's my simulated sampling distribution. And now I'm going to click on find the probability for the sampling distribution. And I want to take what happened in the one sample. When I shot the 50 shots, I made 32. So if I want to know what percent is at or below 64%. And that's going to pop up right here. 7 out of 1,000 or 0.007. So what you just did with the online spinner, I got 76%. It's just going to show you one of these values on the simulated sampling distribution. I had you do that just so you can get a sense of how we're building the sampling distribution. Every one of the values is a sample proportion of number of shots made out of 50 from that one random sample of 50 shots. Okay, so what percent of the dots are 64 or less? I don't care if it's written as a percentage or a decimal, 0.007 or 0.7%. So when I go to interpret this in context, like, remember, this isn't me shooting, this is an 80% free throw shooter shooting. So I'm making an assumption that I am, assuming Mr. Mills is an 80% free throw shooter, there is a 0.007 probability, and your probability is going to be different most likely, of getting 0.64 or less purely by chance. So the likelihood that an 80% free throw shooter makes 64% of their 50 shots or less is really, really small. So now we kind of lead into this idea, well, if that's the case, do we have a lot of evidence that maybe Mr. Mills is lying? Yes, we do. Because it hardly ever, an 80% free throw shooter hardly ever makes 64% of their shots or less by chance. Remember, we're assuming that I'm making 80% of my free throws, and that whole sampling distribution is based off of that. So I'm going to say because this 0.007 is less than 0.05, that's our threshold for statistically significant. That means the results are statistically significant. So we have convincing evidence that Mr. Mills, that's me, is less than an 80% free throw shooter. Could we be wrong? Yes, but it's very unlikely for an 80% free throw shooter to make only 64% or less of their 50 free throws by chance. Okay, let's move on. So here's where we're headed. We're going to state what's called a null and alternative hypothesis for these significance tests. We're going to interpret a p-value, and we kind of just did that. And we're going to determine to see if our results are statistically significant at some significance level. And that's kind of like question number 5 that we just did and question number 6 from the previous page. So here's the idea. For hypotheses, you only use parameters. We're never going to make a claim about what happened in the sample because we know what happened. So you'll notice here, population mean, population proportion. Those will be the two that we use most frequent. So this is called your null value, which is your claim. Your claim. And you'll notice H sub O, that's called the null hypothesis. The alternative hypothesis is H sub A. It doesn't matter if you use lowercase or capital. You have some options here. You're also going to put the null value here. So your options are greater than, less than, or not equal to. Greater than and less than is what we call one-tailed, and not equal to is what we call two-tailed. And we'll get into that more in the next few minutes here, I guess. So the p-value is really a conditional probability. It's if the null is true, there's your condition. Given the null is true, it's the probability of getting sample results equal to some number, or more extreme, meaning further away from the mean, purely by chance. So essentially what that means is, say you have a sampling distribution. All right, so the free throw question, there's 80%. The sample result was 64%. We want to know what's the likelihood that an 80% free throw shooter makes less than or equal to 64% of their shots. This is the more extreme part, further away from the mean. All right, conclusions. We either do or don't have convincing evidence for the alternative hypothesis. And the way that we tell is we look at what's called the significance level. And that's what we've been using for our threshold for statistically significant. Alpha, our default is 0.05. It can change. So what we do is we compare our p-value to our significance level. And if the p-value is less than, in this case, 0.05, we would say the results are significant. So you'll notice I did that on the previous page here. That's the p-value, that's the significant level. Therefore, we have significant results, or statistically significant results. All right, let's move on. So what we're going to look at now is actually coming up with the hypotheses. So what is a significance test? Basically, we're using data from a sample to weigh evidence against a claim in favor of another claim. So it's kind of like the court of law. Do you have you're assumed innocent until proven guilty? So as the jury, do you find convincing evidence or do you not find convincing evidence? That's where we're going with this. So there's two claims. The null is the true value of the parameter is as claimed. And for 99% of the questions that we will ever do, as far as test goes, the null hypothesis will be equal to a number. The alternative, we think that the true value is different. We might believe it to be higher, lower, or it just changed. It's different. And these are a couple key words to look for in the problem to tell you if it's a not equal to. They'll say, is the claim different? Has it changed? I said this before, it's worth stating again. The hypotheses, you're only ever using your parameters, you're never using statistics. These are claims about the population because we don't know the parameters. All right, so learning target number 1, state the null and alternative hypothesis for a significance test about a population parameter. So here we go. At the Hawaii Pineapple Company, managers are interested in the size of the pineapples grown in the fields. Last year, the mean weight. Okay, that tells me it's quantitative means. From one large field was 31 ounces. Again, I see units. This is means. A different irrigation system was installed in the field after the growing season. Managers wonder how this change will affect the mean weight of the pineapples grown. Okay. Be sure to define the parameter of interest. This is in words. Take your symbol and put it into words. This is quantitative, so I'm using mu. And that would be the true mean weight of pineapples grown in this field. All right, so the parameter is mu. So now for the null hypothesis, the claim is it was 31 ounces. So H naught is what they'll call this, or the null value. Mu is 31 ounces. The alternative It has to be the same number. These will always be the same number. Always. This has to be the same symbol. Now it's just greater than, less than, or not equal to. So they want to know how this change will affect the mean weight. They haven't given us a specific direction. This is going to be not equal to, meaning it's a two-tailed test. Okay, for the check your understanding here, why don't you pause the video and work through these on your own? It's the same idea, identify the parameter and then write the hypotheses. So go ahead and work on that. For part 1, according to this website, 85% of teens are getting less than 8 hours of sleep a night. I'd argue that it's like 96%, but anyway, Jamie wonders whether this result holds true in her high school. She asked a simple random sample of 100, how much sleep they get on average in all. They said 75% said less than 8 hours. So they either got less than 8 hours or they didn't. This is categorical. So I'm going to be using the parameter P. And this would be the true proportion of all the high school students at this large high school who get less than 8 hours sleep per night. So you want to make sure you're detailed when you're writing out your parameter, and those words true proportion or true mean need to be in there, or population proportion, population mean. So now we want to state the hypotheses. The null, the alternative, here's what I know. That will be absolutely true. There's the parameter. The null is always going to be equal to some value. The claim is this 85%. So I know that the null is 85% of these students get less than 8 hours of sleep a night. The alternative P is either greater than, less than, or not equal to. This is a little confusing because it's like, oh, less than 8 hours. At first I was thinking less than, maybe you were too. She just wants to know, does the result hold? So if it doesn't, that means it's higher or lower. So again, this is an example of a two-tailed test, not equal to. That means it could have increased or decreased. For number 2, they're talking about census. 10 minutes. I have units again. 10 minutes. Average for the average household. That's not talking about average. Okay, they don't say mean, so it's not as obvious as that one above. So the true parameter would be the true, not proportion, the true mean time it takes to complete the form. So here's what we know. Mu is equal to, this is my null hypothesis, my alternative, mu. Advertise 10 questions, 10 minutes. So my null is that it takes 10 minutes. Here's what they want to know. We suspect the actual time may be longer. So the alternative would be mu is greater than 10 minutes. So that's how you're going to get used to writing the hypotheses. You first have to figure out, is it categorical or quantitative variable, and then use the correct symbol. And then you're just going to extract from the question what the specific parameter claim is, and then use that in your hypotheses. And then for the alternative, you're looking for keywords. Is it different? Did it change? Did it increase? Did it decrease? So that's the first part of this unit. I will make a separate video for the next part.